Hello.
Good morning.
Morning.
How are you?
All right. How are you?
Good.
Great. Jesse posted a link to the Notion in the general channel. Yeah, looks like we have a lot of stuff today, but I don't know if Jesse's gonna be here. He's probably on his way.
He was messaging at like 2:30 in the morning, so.
Oh yeah. So, how are things going with you?
Pretty well.
Great.
Yeah, busy week. For my job, I'm getting to use this EEG analysis tool that Morgan told me about,
Okay.
which is cool. I don't know how successful it'll be yet. I just started playing with it, but
Yeah.
yeah, that's been interesting.
Yeah. Yeah, that's so you're doing a lot of that sort of thing in your job, or?
Yeah, yeah, so I guess it's been like less than a year since I've had this job, and the first maybe half of it was just like data cleaning,
Yeah.
which was like fine.
Yeah.
I didn't mind, and I was also like I had to learn. I don't know. I had a lot to learn, and I still do. But it's good to have gotten to a point where I can do more on my own, and I still have to, of course, like check in with the postdoc and the grad students I'm working with. But yeah, I've definitely learned a lot.
Great. Yeah, great. That's pretty good. It's always a good experience to do something like that. You get like you get to use software, but also you get to understand the data firsthand and really dig into it.
Because I've had an interest in it. I did a little bit of EEG stuff in undergrad, just like real surface level, and I had an interest in it, like just from the philosophical standpoint. Like it seems like a really promising way to study the brain, but I've been enjoying actually getting to do the science.
Yeah. Yeah, I think that was a pretty good meeting we had. Wednesday and Thursday. So we had cognition features on Wednesday, and then human use of human beings on Thursday.
Yeah, I liked the brainstorming we did on Wednesday. It seems like the plan is to kind of formalize that a little during the next meeting, like maybe turn that pyramid into a more organized, like typed out document.
Yeah.
Yeah, I'm glad so many people were interested in the Weiner book. I was really just like, I want to read this book, and I will ask the various people, various groups I'm a part of, if they want to read it with me, and got quite a few people. So
yeah,
I'm really looking forward to that.
And so yeah, you got people from I guess Western Michigan University, and
I'm doing a reading group with them. We read some stuff on predictive processing, but it's all been like philosophy.
Yeah.
We avoid a lot of the technical details. And right now with that group, we're reading The Dynamics of Acting, which I've mentioned a couple times, which is a philosophy of action book. So it's definitely philosophy, but it takes bits and pieces from like dynamic systems theory mostly, and then information theory a little bit, to try to explain ideas that have not been discussed very well in philosophy of action.
Yeah.
So
that's great. See what we have in the Notion here. So finishing NCWIC, I think that's pretty much done. We have this post that I put up. It was the introductory post, and then Jesse wants to write a longer post, but he's not finished with that yet. That's more of a reflexive exercise.
Mm-hmm.
Then I think that's done for this year. So we'll have to come back and think about it for next year. Pick up, this is part of the Society Ethics and Tech project. So we always tend to forget about it for a while and then come back to it when NICWIC is kind of in swing. So I don't know, maybe there's some things we can follow up from on that. Number 2, GSOC prep ahead of selections. So that is, I guess that's coming up this week. The selections are announced. So good luck to everyone who applied. I think Tuesday or Wednesday is the day. So I think the first is Monday, so it's like the second or third. So yeah, good luck to everyone who applied to that. Hopefully we get our slots. I know that I was asked to make some recommendations, and then they kind of see what they have, and they give you the slots that you get. So I haven't heard anything back since I submitted those, so hopefully it'll be positive.
Do they pick particular projects?
Well, they usually pick, usually every project gets one person, but sometimes not. It depends on the group that's applying. Like I've applied under both Orthogonal Lab and OpenWorm for several years, so I usually get some priority on that. And so, but last year we got like everyone who applied, so that was a pretty easy decision.
Yeah.
But I haven't heard anything back this year. So then, yeah, like next week we'll be getting into the community period stuff. So that's going to be interesting. I think we'll probably try to do like an open source meeting on Fridays. So that's, I don't know what time yet. We'll have to work on that. I sent out, I don't know if you get Amanda, if you get the weekly email that we send out for the lab. So I put a table in that email, and I proposed, well, I just listed the meeting times of the current meeting schedule. So, it's like Mondays we have DevaWorm. I think Wednesdays we have Cognition Futures. Thursdays we have Human Use of Human Beings. Fridays we have like the open source meetings. And Saturdays we have this meeting. I mean, the way I want to do it is, we'll have like the regular meetings that happen every week or every other week. And then we can have these like seasonal meetings where, maybe if we do something over the summer or at a certain time of year, we can have meetings that are sort of on the schedule. I haven't put the schedule up, but it'd be kind of a good thing, I think, for onboarding purposes to have like a little schedule, a timetable of different meetings that are happening. So do you envision the Human Use of Human Beings to be like a long-term meeting, a long-term group, or do you envision it as changing topic, or how do you envision that?
I haven't really thought about it past this particular book. I mean, there are plenty of other like cybernetics books or maybe other things that fall under the Society Ethics Tech banner that I would be happy to read. So it just depends on interest. It seems like Jesse set it up under the banner of Society Ethics Tech, which I think is a good idea for like advertising and getting people involved. So I don't know, maybe when we finish this book, which will be in a while because of the meeting every other week, but maybe towards the end we check in.
Yeah, I think that's a good way to do that. But yeah, eventually I'd like to have a more formal list of things that we're doing in the lab so people can join in. So yeah, that's good. And like I said, we have the reason we have some of the meetings in the mornings is because it makes it easier for people from other parts of the world to join in. We do in the evenings, sometimes we can't help it. Sometimes people can't join in, but That's why we do the asynchronous part too. So looks like Jesse put in like he got a live stream and it was pretty good. So put that in the channel. I think it's in the actual let's see, RGHUHB channel. So he put that stream in there. So great. Yeah, he's got things on his YouTube channel, and I have a lab YouTube channel. So those are two. Sometimes you get sent to his, sometimes to the lab channel. So yeah. So I don't know anything about the We Robot decision. Not to paper suggestion for posters. I guess we didn't get the paper in there, but you got posters. So there's I don't know what the topic is. I guess it's just a rehash of the shared interfaces. Yeah. So I sent Jesse a message. See if he's around. Sometimes he oversleeps, so.
Yeah, that's why I mentioned that he was just sending messages at like 2:15 or whatever. I'm not sure what oral discussion series means. Do you?
Let's see.
I mean, I can imagine, but.
Well, yeah, let's see. We talked about this the other, like last week. Like having discussion series where you talk about things sort of more off the cuff. So like you pick a topic and you kind of go through it, maybe 2 or 3 people where you spend a little bit of time unpacking some things. Like in this meeting, we talk about a lot of things and we give it like maybe 20 minutes or something, maybe 30 minutes, but it's not like a long, long-winded thing. So.
Yeah, I remember now. It was in response to the demons.
Yeah.
The demons, which, I like that idea. I guess, I don't know, that's kind of, it seems like that's always an option for people, right? If you say in the emails, like if you're interested in talking about something for 5 to 10 minutes, go for it. So I want to maybe do that more because I find it helpful for myself when I'm trying to understand something to be able to explain it.
Yeah. Yeah, I think so. Well, I mean, we talked about the one, like the sort of the cognitive science session where we all pick a paper and go through it. I know it's been like hard to find a time, and then we forgot about it, but I still want to do that. I think
maybe that could be a good thing to do in Cognition Futures, like for our next paper choices. Maybe even for like next week, we pick some of the papers from that trends in CogSci issue, whatever initially, prompted the discussion series idea.
Yeah, that would be great. And then, we could unpack it for, however long it takes. It's, one of those things where, you don't want to limit yourself to 20 minutes because you want to really kind of unpack maybe certain things. And then, kind of focus on, I still think, if we're going to, I still think if we're going to do something like that, we want to have sort of, give it some deep thought, like in terms of some of the suggestions that they make and how we might critique those. We don't really do a lot of that in the group. I mean, we do some of that, but it's kind of like, I don't want to take, in other words, I don't want to take what they're saying at face value too much. Because I want to see how that fits into what we're doing, say, or we talk about a lot of different things. So it's like, how does that fit in all of the scheme that we talk about? Because a lot of people, they'll have their pet area. It's like cognitive science should be this way, and it's of course their way, right? Like always what they're doing.
Yeah, that makes sense.
Yeah.
we should be more critical than maybe we usually are.
Yeah.
But I like that maybe if we do it in Cognition Futures, the output can be like an annotated bibliography entry where we try to like type out our criticisms.
Yeah, I think so. So it looks like we had someone, Ravindra, but I don't know what happened trying to connect to the meeting. So yeah, I don't know. Welcome. Yeah. So I want to. Oh, there's Sushmanth. Hello, Sushmanth.
Hi, Bradley. How are you?
All right. How are you?
Fine. Just thought I could attend meeting. I was free now. That's the reason I.
Okay. Well, welcome. Yeah, we'll be talking about a lot of things today. Stay as long as you want. Yeah.
And a small update, actually.
Okay.
I want to mention you. I was approached by Hugging Face team to host our development model as their transformer. I was thinking to work on it. I told to Mayuk yesterday about this thing. He told like we can host it, and he want to connect our model with SAM, Segment Anything model also, which is released by Facebook. We can integrate and better segment more. And another thing is graphs. I think we can host a demo app like our cell segment and membranes are there, right? Exactly like we can host a DGMN into Hugging Face right now. They are developing a feature, so I was thinking to work on it. Before working, I just need to mention you about these things. Actually, I showed them like their message about Hugging Face and all this stuff. He told to once discuss with you about hosting the model library into a transformer. And whatever model was built is an encoder model right now in Roland. So that's actually they are interested in it. They told like they write code for it and submit that one as a model library to them.
Well, that sounds like a great idea, actually. What was that?
Can I share my screen?
Oh yeah, go ahead. Yeah.
See, I mean, right now, how could I show? Yeah, this is Model Hub. Actually, every model can be made and can be hosted here. There are different. I can show you the docs. Okay, models. Where it is. Transformers. Yeah, this is what I'm talking about. We need to write code according to this, and we can show them. These are supported models. Albert, Align, etc. Like this only we can host Devolan and create a documentation for it and host our model and data sets. Actually, we can host the data set as this one, big data set or set tracking challenge data set to train our model. And after doing that, we can just everyone can see their models here. And this could be the first and only the model on neuroscience which is hosted on Hugging Face. Right now we have the tools, but a model library wasn't there. So that's what.
Yeah. Well, that looks great. Yeah. So just to be clear on how they work at Hugging Face, so they work with you when you like. I mean, they
right now
tend
I
to
was
be proactive.
actually I was contributing to it since the spirit is there. Right after proposal time, I got so much free time. I was working on my thing and I was contributing to Hugging Face. So I was contributing to a model, Facebook model, SAM. Right now I'm learning the architecture of it, how the transformer models are hosted and their library structure. There is certain type of structure to write code for Hugging Face. They are maintaining it. According to that only we should write it. So right now I was learning it. It's not kind of easy thing. I mean, right now till now I worked on Hugging Face pages, but this was completely different. I need to learn a lot more to implement it. So I was first learning, and I will start working on it within a month or maybe.
Yeah, that sounds great. Yeah,
and the community is most welcoming. They are helping me a lot. Whenever they're getting it out, they are like responding me in Discord. They are messaging personally, and even they are talking in the GitHub issues.
Yeah.
And actually, I mean, before that, Mike just told to, can I keep your mail? I want to give them a mail ID. I mean, first they will keep a request to you about the model. Then I can start working on it. So there is no official email ID for Devolan. So I think, can I give yours, or who could I give? Which one?
What do you mean? What, email or?
Yeah, email.
The OpenWorm email. BAICEA@openworm.org. Let me type it in the chat.
Okay. Before start working on it, I keep a mail to either your mail ID or something, official mail ID for Devolan. Then he checked and he like there is no mail ID for Devolan, so ask once Bradley about this thing and then you can give it.
Yeah, we don't. Yeah, we just kind of use it informally, like, you know, that's what I have for the organization. So we don't usually get that much mail, so it doesn't really matter. Okay.
I will give this email ID. You can. They will text you up maybe within this week or something like that. Okay. After that, I'll start working on the model also.
Yeah, that sounds great. Yeah, looking forward to it. So yeah, I hope, you know, we can get the GSOC. I think this project will get, you know, selected. So yeah, I think it's looking good on that front, but I don't know for sure. But that's we'll find out Tuesday or Wednesday about that.
Yeah.
And then we can get going.
I was also a little bit psyched. I mean, don't take this in a wrong way, but India, there is a thing like, there is an exam actually after 12th, the JEE, Joint Entrance Examination for Engineering. After that, generally people see GSOC as some kind of a big thing. I mean, my dad is psyched. He called it to Mainak and he was talking, he will get it or not, all this stuff. So
yeah,
I was also worried like whether the project will get a slot or not. That kind of stuff is going on.
Yeah, I think so. Yeah, I mean, you know, again, like I don't know for sure, but I always, because I've been kind of, you know, I've been burned before on that, I guess. But you're not supposed to tell anyone, you know, anything before the date. So
yeah, I understood. But is my proposal good enough? I mean, every time I was getting this gut feeling like it is good enough. I need to add something more to it.
Oh, I think your proposal was great. Yeah, it was very good. I enjoyed reading it. I thought it was very good. Had a lot of, I mean, really, I mean, the standard should be kind of, you know, you go through a proposal, you go through the problem, you give some screenshots, you give some evidence that you've thought it through. You don't need to like implement anything, although people tend to. And then the conclusion. So you had everything there. It was pretty good.
Yeah. Actually, I wrote the code for the model also, but it was wrote in Chainer. There is a framework called Chainer. But Devolan is completely on PyTorch, so I was converting the complete code into PyTorch. It's kind of big mess. I was working on it only, and another data set also I find to pre-train the model. Actually, Mayuk is helping me a lot. Mayuk and Mainak. I mean, they told like maybe after May 4th they will join in one meeting with us to discuss the project idea.
Yeah, that would be great.
To implement paper completely. So that's it.
Yeah, because they're 2020 and 2021 respectively. They were the GSOC people, so they kind of built this whole thing around Devolan and like what's there now. So
okay.
Yeah.
They told like Mayuk will join. I don't know about Mainak, but Mayuk told he will join in the upcoming meetings to just see through. Actually, he was interested in the model. He was giving some ideas also. Mainly this thing. I think you could see this model. I am sharing the link. It is completely good. I mean, we can integrate completely with Devolan. This is a SAM model from Facebook. It's too good. I mean, it is segmenting very perfectly. I have tried on C. elegans data, and it is working so good. I couldn't mention like.
This is Yeah, segment anything model.
Yeah.
So let me share my screen here. I have it pulled up. Yeah, this is where is it? Here it is. So yeah, this is Hugging Face. They have a really nice open source operation at Hugging Face. It's like they're they have a lot of open machine learning models, and they really do help people work with them, work through them. So this is this is great to be connected uh, with Hugging Face. So this is from Facebook Labs or Meta Labs or whatever it is. Their AI.
Actually, I have sent another link. Can you open it? I mean, there are segmentation results in them for mainly for cells. I mean, it is working very good.
This is segment anything. Okay.
Yeah. This is documentation
demo. Yeah. Okay. Well, I guess not. They're not. Oh, except there. Okay. All right. All right. This is Meta AI. Yeah.
Cells one. This is the cells image. Yeah. First one.
The which one? This one?
First one.
Okay.
First one. Yeah. I have trained with C. elegans model also.
Oh wow, this is great! Like you can actually do things in the interface. So if I want to click on something, I can add mask, remove area.
Can you click on everything if possible? Everything, the down icon.
Oh, everything. Yeah. Okay.
Now just a minute. It will create the segmentation image of it.
Oh wow! Okay, I see. So it's creating this mask with all the
particular cells only. Yeah.
Yeah. Okay, that's great.
And I tried with C. elegans. It is working very smoothly. I think. I mean, I can't tell the segmentation results. I want to create a PPT about it, but I was busy last 2 days. This is kind of stuff we can calculate volume, etc. To this also. This is called instance segmentation. Yeah, this is how it.
Yeah, this is of course great for like things that don't have. We've been talking in the DevoWorm group about how to improve upon DevoLearn. We've also been talking about how doing instance segmentation versus semantic segmentation for like an organism. If you're dealing with something like C. elegans, maybe an embryo, or maybe something where you have different tissue types versus different cells that are really defined. So instance segmentation will pick out cells like that, and you'll be able to classify them later. But you're picking cells out of a background, so these are all the cells and they're outlined. Or you can have semantic segmentation where you have like tissues or something with labels, and then you can use that. And so I like that we're getting this sort of because we have the problem in development is that you have a number of different stages where you have different types of data. So you have like the cells that are unlabeled or undifferentiated, and then eventually you have tissues where you have regions that you can classify depending on the organism. Those labels or you don't. So sometimes the developmental cells have labels. Sometimes it's the tissues that have, of course, a label. Sometimes if you have an organism that you don't really know the anatomy of very well, you don't know what things are. And that's something that you find in like a lot of biological imaging and medical imaging, is where you have structures that you can register with you do what they call an anatomical scan, and you can identify different regions. They do this with the brain, where they have like different regions of the brain, and they have to parcel or parcellate or segment out the different regions. So like certain cells belong to certain regions, but it's unclear sometimes what region something belongs to. And they've been doing neuroanatomy for about 200 years, and they still don't really know what some regions what they belong to, if they belong to one structure or another. Occasionally they find new structures, or they propose new structures, and they say this is a new structure because we think the connectivity is such that it's different than anything else. So there are a lot of problems like that where, and in fact, a combination of techniques might be warranted in a lot of cases because we just simply don't know enough about what we're doing to say definitively what something is. So yeah, I like this. I like this approach. We're getting some good machine learning models, and we're working with Hugging Face, and we're kind of exploiting some of the newer models. But one of the problems with some of these machine learning models is that the technology moves so fast that you can 1 year you can be on the cutting edge, and then the next year you fall back, and there's always a new cutting edge. So it's very hard to keep up. This will help us hopefully keep up a little bit more because there are always new ways to do things. The other thing I wanted to point out here is that I like the idea of a transformer because I don't know if this was something that we had in the OpenWorms, in the DevoWorm Slack. We have in the OpenWorms Slack team, we have 2 channels for DevoWorm. We have DevoWorm and we have DevoLearn, DevoGraph. And I think in DevoLearn, DevoGraph, we've been putting papers in on graph neural networks. So the graph neural networks literature is it's kind of like there aren't a lot of conventions in the field. So it's hard to know kind of what the standards are, if there are any standards. There's some techniques that are emerging that are becoming more, accepted, I guess, as the consensus, but it's still pretty, open. So I actually, in last week's DevoWorm meeting, I did about an hour at the end of the recording, and I did like 4 papers that we've had in that channel, and I did a deep dive into those papers. So if you want to check that out, it's on the DevoWorm YouTube channel, and it's meeting 15. And in meeting 15, the tail end of it, it's like an hour. I kind of went in a really deep dive into some of these papers. So there's the standard graph neural network techniques. It's like taking data, extracting a graph embedding, and then maybe using that for prediction. There are other techniques like integrating things like Hamiltonian graph methods into more traditional neural network approaches. There are other types of network formation and visualization. And then one thing that was pointed out in one of the papers, and I can't remember which one, was that your standard transformer model is actually sort of the basis for graph neural networks, where there's a connection there between transformers and graph neural networks. And I can't remember how they were making that connection, but I think that having a transformer model of what we're doing opens up that door. Maybe that makes it easier to implement a GNN that does certain things that we want to do.
Okay. Oh, nice.
Yeah.
Now I understood. Okay. Now everything was making sense to me. I was reading a paper 2 days back. I think I read that paper. Actually, there is a connection between transformers. There are 3 types of methods in it: encoder, decoder, encoder, and decoder. There is a connection between encoder and the graph neural network. Some connection is there. There are a lot of math involved in it. I left it. I read half paper and I left it. Okay, now I am understanding. Yeah.
Yeah.
Cool. I will. Anyways, I will work on this transformers thing. I need some time to understand this architecture of Hugging Face. Actually, if we write any code according to our wish, they will not keep there in their repository. So I was thinking to learn the architecture and implement the code in those Hugging Face way. So it takes time. Maybe this could be some Hacktoberfest, what we call a task or something like after GSOC, after an instance segmentation model is host, we can create the both instance segmentation model and semantic segmentation model into Hugging Face as a library. So that would be a perfect plan. This could be a next GSOC project also next year if it's possible.
Yeah, I think that would be good. Yeah, I think that would definitely, if we can get that up this year, we can do that for Hacktoberfest and then next year's GSOC. I know we haven't done a Hacktoberfest. We did in 21, I think, pretty
Yeah,
successfully.
I actually participated
Oh,
in
okay,
it.
yeah. Yeah, that's good.
Yeah, those are my updates. Anyways, thanks, Barry.
Yeah, thank you. Yeah, so we don't talk about DivaWorm that much in the meetings. Occasionally we come about like some updates, but I think this was a nice update because I think we kind of bring it up in kind of passing, but we don't really get into it too much. But so thank you for being able to be here and give us an update on that. We do in this meeting. We do talk about machine learning and deep learning. We do other things with those methods. And I'm looking forward, maybe in the summer to having more cross fertilization. The things that we're doing in this group are not really image segmentation, but there's a lot of interest in kind of more general deep learning models and some of the philosophy behind them and other things. So, we'll see when we get to the community period of GSOC, we'll see what people are interested in, and we'll then can maybe make some decisions accordingly. Okay, so that's great. So I'm going to talk a little bit about something that I've been working on this last couple weeks. I kind of hinted at it earlier. I don't know if I did last week or not, but I've been working on doing things in virtual reality in the MetaQuest headset. So if you're interested in following along, what I'm trying to do, I've been trying to do this for a long time, is to present things for people so that they can do their own work in these areas. So, like, one of the big things is like meeting in virtual reality, working in virtual reality, and then maybe like building different types of tools in virtual reality and then working with them on your own. Or, if we have a model that we want to distribute to the group, everyone's in different parts of the world, they can download it onto their headset and use it in their own place. They don't have to go to a centralized lab to do these things. So that's kind of the idea. It's very slow going because one thing I found out about, well, I've been working in VR for a long time. So I worked in the 90s, I did Vermal, which is a virtual reality markup language. I worked with Vermal in the late 90s on like web pages and built some models there. And then like in I think 2001, I got into my first cave environment. And so I was at a university and they had a cave setup, which is like where you stand in the middle of a bunch of screens it envelops you like a cave. So on three sides you have projection screens that project images. And you could be like in a landscape where you have a camera that's filming in front of you, a camera from the sides, and then the scenes are connected so that you feel like you're walking through, like, say, a field, and you're walking forward and sideways. You can see sideways, and it's what they call immersive, which means that you're enveloped in that scene. And then on the floor they have a speaker system, and there are all sorts of stimuli they can deliver to people. So that was 2001. Then 2003, I started working in a lab where we had headsets. And back then, of course, headsets were very expensive. They were like thousands of dollars. And the tracking system was, bolted to the ceiling. So we had this tracking volume. And we had, so it was nice. The stimuli were very crude, but still at the time, that was pretty cutting edge. And so in the last decade, I think, there's been a push towards commercial VR. So commercial VR is where they're putting like video games into headsets, and the headset is immersive. You wear it over your head. You see you don't see anything but that. You can go. There's a mode where you can go to a pass through, which means you can see through the cameras out into the world. But If it's virtual reality, it's this thing where the whole scene is immersed. So it's instead of like, say, just looking at your screen, you're looking, around. You can look in you can look all the way around the back of your head. You can turn your chair around, and you'll see this world. And so you're immersed in it. So that's the motivation here. I've put some of these videos on our YouTube channel. Actually, let me make sure. Yeah, I'm sharing my screen. I put some of these videos on the YouTube channel. What I've been doing here is this is demo or die examples from MetaQuest 2 in virtual reality. So this is something that, of course, you're familiar with Jesse's term demo or die. It's not his term, but we talk about it a lot. It's basically where you present some demos and you kind of, it's like a proof of concept thing, and you figure out why they worked or didn't work. So this is a series of things just showing how to get into the what they call the metaverse or virtual reality or whatever you want to call it. And, some of the tools that you can use to get in. So in this video, I talk about, getting into the main area of the environment and then booting up some of the programs. So we go through Meta's Horizon Workrooms, which is a platform where you have like this office space that you're in. It's a virtual office space. And then you have screens and a whiteboard that you can play with. You can project your laptop into the virtual world so you can see your laptop screen on the screen in the environment. And, you're able to work. You can like take a wireless keyboard, connect it, so you can see, and the keyboard shows up in the environment so you can see what you're typing. And then you can work in the environment effectively. It takes, one of the things about a lot of this stuff is it takes like 5 or 6 steps. So some of this stuff to configure it takes, quite a few things you have to set up and you have to manipulate. So it's not entirely seamless. It's not entirely what they call frictionless, but that doesn't, I think last week or the week before we talked about VR, John Carmack's, some of his observations about VR. And one of the things he said was the experience needs to be seamless. And one of the things about our vision here is that it isn't seamless. There's still a lot of work to do in terms of making this like 1 or 2 steps where you can just set it up. So, it's not bad working in VR. You maybe, for some people it's more comfortable than others. You do tend to get this fatigue, if you work in there a long time. You also get this, it's also very clumsy sometimes. There are glitches where you have to, you have latencies, but you also have, where you're trying to figure out, how to work with things. So if you're working on writing a paper, say, in your normal situation, your normal setup, it's pretty straightforward. You type on your keyboard, you look at the screen, look at your notes. In VR, it's a little bit harder. So it's it takes some getting used to. So I show a bunch of demo examples here. There's also a web browser, Wolvik, which is an immersive web browser. There are different other platforms that you can use for projecting things onto screens. So you can actually have like a multi-screen setup in virtual reality, whereas maybe in real life you only have one screen. So you can do stuff like that. Then I created 2 presentations. So I've been experimenting with how to present in virtual reality. Taking like some slideshows that we've had in the lab and projecting them onto a screen, and then leveraging this virtual environment in ways that are, and maybe improve the experience of watching a presentation. Instead of just watching slides on the screen, you can be in a little theater. So this one is where I talk a little bit about our developmental AI roadmap, and I present it in a theater scene. So I use some pedagogical examples where I look around the theater, and I kind of leverage that spatial component for that. And then this is the classroom. These are both in big screen VR, which is a program for the Meta Quest, and it allows you to basically, have little meetings in the virtual world and project your screen project your laptop onto these screens, and then sit around and watch things or present things. So it's a nice tool. This one is on our PHASIC, which is Physical Intelligence Augmented Systems, and Complexity. That's the name of that initiative. This is an overview of that, and I'm presenting it in this classroom. So I'm not using the spatial component as much here, but still you get the sense that, you could do that. What I mean by the spatial component is like look around the room, use examples like if you're thinking about stimuli coming from different directions, you can look right, look left. It provides the cues that you might get from, that you might get in a real talk, that in a virtual talk you won't get it. You'll just get like, I'm looking at my screen, I can describe things in words, but I can't show some of these different spatial cues that we might get. So that's the Metaverse for Research channel. I'm going to add more to it as I do more experiments in this. I also want to point out that we have a Discord channel, which is Principles of Bits to Matter to Mind, and this is something that we have a link on from our main webpage. So this is a Discord server. We have a couple Discord servers in the lab. This one is something that I've been working on, putting different topics and events and methods into this sort of format. So basically what I've been going through is I've been doing these experiments, and we've been talking about our GSOC project this summer, which is VR based. And we're doing all this stuff with different topics, and I've been sorting out some of the readings and some of the materials for these topics in these different channels. So we have a bunch of topics and methods, and then some community tools for working open source. We'll focus on the topics and methods. So the topics are virtual reality, which is a general overview of some tools for VR, different demos and other things. Then there's a network science, which is, this is just talking about network science with respect to open source. This is sort of a legacy channel. We haven't put anything in it directly related to VR, but I think there's a connection between network science and VR that could be I'd be interested in exploring. The reason that I have this server is so that I can get, different topics assembled. Maybe we can get some readings in here, and we can go through then and write papers or write up reports that are informed by the fast-moving nature of this field. Because there is a lot of stuff that you encounter, and the field is moving fast. You're getting a lot of different demos and different ideas, and you have to be familiar with them. It's hard to really crowdsource that effectively. So this is one way to crowdsource this. So this is closed loop feedback, which is a topic that we sort of overlaps with sort of like cybernetics and control theory, but this is more relevant to VR. So this is where we have thermal feedback and interfaces, which is like I said, in your interface, you get these, signals, these sensory signals that you interact with. Sometimes if you're touching an object, you want to know, have cues in terms of the feel, the touch properties of it. Like if you touch a cup, you want to make sure that it's solid. If it doesn't respond in the way that you usually grip a cup, it's very hard to know kind of what the boundaries of the cup or how it functions as a cup. So thermal feedback is also important. If you touch something like an ice cube, you want to feel the cold nature of the ice cube, the freezing feeling, the thermal aspects of it. And if you don't, then sometimes you get confused. It's a very subtle thing, but there are things like that that are interesting in VR. And that involves closed loop feedback. So if you look at this, we have a number of different things on feedback, closed loop feedback. One thing that was interesting is that there's this thing that there's this idea of having legs in VR, and Zuckerberg made a big deal of having legs in VR, and people are kind of laughing at that. But one of the problems in VR is to have effective like ego motion with respect to your legs. Apparently, when you are in VR and you're in this enclosed environment, in this immersive environment, you can't necessarily have legs that aren't, if they're not well synchronized, you get motion sickness. So it's hard to have like legs rendered on a body when you're moving in a headset and those aren't synchronized. So you're looking at the legs in the virtual environment, your legs are moving in a certain direction. In the virtual environment, they're moving differently. And it's confusing to the point where you can become disoriented. So there are different ways that people have dealt with ego motion in virtual environment. Some of them is using a motorized treadmill, and some of them involve tracking of the lower body. So there are different strategies, and I'm putting those in the channels here. So we have other topics here, new robotics, towards XR, then the channel and working. So kind of talking about some of the things I just showed were, how do you work effectively in VR? How do you like synchronize the types of tools that you use for working like on a paper on your computer, on your laptop? How do you implement that all in VR? Topics like haptics, where we deal with haptic feedback as well as some of these closed loop feedback topics. And then methods. So then methods, we have different types of data sets that are available where you need information about three-dimensional objects or body tracking. There are other types of things, experimentation. There's the interaction between VR and AI. So we have VR, of course, which is this, simulating objects in different modalities and interacting with them. AI can assist in some of those processes. We don't really know what the connection is, but there is a strong AI component to VR. Then we want to have concepts with some precision. So we have some things in here on like building concepts and refining them and making them relevant to, the world. We don't want to have these concepts that are floating out in the world and don't have any meaning, or they don't have any relevance to what we want to measure. And some of these involve some of the tracking engineering. Some of them involve some of the ways in which people are presenting VR as like the future, or that it can do things that it really can't. And some of this involves like even human physiology. So there are ways that which you can render images to the eye, for example, that leverage the physiology of the eye. And they call one of those things foveated rendering. But there are other ways that you can do this too. So it's a very exciting area. It's growing. There are a lot of topics to cover, a lot of concepts to cover, and we need to have a place to do that. So that's why I did this. So it looks like Jesse's here. Hello, Jesse.
Hello, sorry for my
Okay.
delay. I missed most of the video stuff that you might have showed, but I did
Yeah.
see some of them on YouTube, and it was cool to see.
Yeah, great. Glad you could make it. We were talking about some things from DevaWorm, and Sushmant was talking about that. And then I talked about some of the VR stuff. I went over the Discord and our video channel. And then I want to talk about one more thing in terms of VR. So there's this, as you're aware, Meta, which is Facebook plus some research organizations. So they do a lot of AI research in Meta. They also do a lot of VR research. And so the VR research has been, they've been trying to build this vision of the metaverse. Like I said, VR goes back many years. There's consumer VR. There's this build up towards building products and having the infrastructure laid out so that people can go in and do things seamlessly and in a frictionless way. So one of the things they've been working on is sort of a roadmap forward. So right now we're at the stage where we have this commercial VR. It's pretty decent, but it's not great. Depending on the applications they're using, it can be a nice experience. We want to basically have a roadmap so we can get to a point where we can standardize a lot of this and we can build around it. And so this is something that they recently, the executives at Meta laid out plans for the road ahead in VR. And so for their corporation or their organization, their roadmap for the next 4 years includes 3 new Quest headsets, AR glasses in 2027, and a neural interface smartwatch. So this is an example of like a roadmap where you're planning out new things and new directions. And of course, the problem here is that you need to kind of pick things that you can do that you already have the sort of you have some grounding in. Like you can't just pick something out of thin air that you're going to achieve. They've been working on augmented reality or AR for a while, and it's harder to do than VR because you have to lay virtual objects over the real world. So effective AR will, lay objects over the real world seamlessly. Those objects will be easily sort of referenced, and then they'll track with the user. So if I turn my head, the object should track with my visual field. It should be in the same place that the place it's supposed to be, and it should have some way to interact with other things in the environment, so that things aren't just moving around, or you have to make it seamless. So they the headsets part, I think that's probably in reach for their organization. They've been doing headsets for quite a while. It's really a matter of like figuring out what kind of projection system to use. So there are all sorts of ways that they project images. There are different camera schemes. There are different types of optics or glass that they use to project things out into that space between the headset and your eyeballs. And then having different ways that you can interact with, with technology. So this neural interface smartwatch is where you have a smartwatch and we've talked about the interfaces where you can put a headset on and get on your forehead, not on your eyes, and get signals from the prefrontal cortex, and it controls a smartwatch or some other device. So that's what they're proposing here. So their first pair of full-fledged AR glasses. So a lot of you can, in MetaQuest, you can do AR. You can do this pass-through mode where you can see the world around you, but the cameras for the pass-through mode aren't great. So some headsets are specialized for, this AR mode where you have really high-resolution cameras out into the world, and then you have these objects that are projected into that reference frame in the field of view, but you can also see the outside world. So they're proposing is to have like a specialized set of AR glasses for this. And then this is something that you can use on mobile phones. So, you'll have the mobile phone aspect that you can interact with. So this is, and you'll use a mobile phone maybe for capturing information about your local environment. Sometimes, you want to sometimes they have augmented reality systems where they'll have a series of markers in the environment, like QR codes or something like that, and they'll put them on objects. And then the idea is you can point your cell phone at the object, take a picture of the QR code, and then that virtual object will pop up above the little logo or the little symbol QR code, and then you can see them with your glasses. So, it's registered in that point in space. If you want to find out more about something, you take a picture of the QR code and it pops up. And so that's the kind of thing they're trying to facilitate. Now, their roadmap, of course, is to build more headsets, to build more specialized headsets, better resolution headsets, and then So they're looking at a Quest 3, for example. They're going to engage more with mixed reality, which is mixing in the actual real world and these virtual objects. And so, again, the guiding principle is always to make it feel good and to make it seamless and frictionless. This is something that's really been a challenge, I think, with VR, because it's really hard to, it's not something we're used to, I don't think, naturally. In a way, we read books, we can imagine different worlds, but like when you're engaging with your senses directly, it can be hard to find a way to interact with that. They're also working on like photorealistic avatars. So the avatars in VR are somewhat, cartoonish, which is fine, except that like when you're in meetings with other people, you want to see photorealistic images. Like I see Amanda, or Jesse. It's like if you had like a little cartoon, that would be okay, but still, you can see expressions better with a photorealistic image. So this is again like a matter of engaging people, a matter of finding good applications, good ways to use these environments. And it's always a struggle. There's all sorts of hardware being introduced all the time. So this is an example of AR glasses, sort of their mock-up of like a chess game where you can play a virtual chess game with someone, maybe with a dead grandmaster or something. You can actually produce a hologram, using an set of AR glasses where you can interact with this person and play a game. But that's all visionary, that's not like something that we can do imminently. So there are all sorts of technologies. So there's a move towards going from the headsets like this to glasses like this. And so you can see the advantage. You don't have this heavy headset on. The glasses are maybe more, especially for like augmented reality, the glasses are more sort of natural. You wear glasses all the time. They're light, so you can project things onto the screen here. Where here, this is very heavy and can be, hard to see things in the real world. You have this pass-through mode, but it's still difficult. So that's one of the things. And then, of course, integrating mobile devices with that, which is a trend, I think, throughout the tech industry, is to make things mobile. Although in this case, especially with AR, it's important because you have, you're interacting with the real world, so you need to be able to move around in it. So that was all I wanted to talk about with respect to their roadmap. So I don't know if that's something that is going to happen in exactly the way it's laid out, or there are other companies doing this stuff that, where they have different priorities, different visions for the future. So, here we go. What is this? A GIF of Jesse?
I actually have no idea. I was looking for a bunch of VR avatars, and a lot of them were like, a lot of things that came from the search were kind of creepy. Like, whoops, it just went away. Like this?
Yeah.
Like, so I don't know. Yeah, I have to go back. There were some things I wanted to ask about a lot of VR stuff, and I feel like I'm a little bit too late for the conversation to say a lot about it. But yeah,
I think maybe we should have our own roadmap. I mean, that'd be something we'd have to develop, but like
a roadmap for what we want to do with VR, or a roadmap for like Google Summer Code projects, or
well, no, I think we can handle, but I think like a roadmap of what we would like to see. Like, the reason I'm doing these experiments is to see what we can do as a research group on it.
Okay, so yeah, because I know there was like, I saw the YouTube videos where like walking through the Dev AI timeline, and there's another one, but I forget what that one was.
It was the I remember Phasic overview.
Okay, and like, because I know we literally have a Dev AI roadmap, but I think a roadmap for like where we as a group could go with using it, like in a practical sense.
Yeah, so like
Um,
what kinds of tools would we be using? What kinds of things should we be on the lookout for? We're not doing a lot of heavy development in the space, so it's kind of limiting there, but like what kinds of tools, because there are always like programs being produced, like people are always putting things together. So what kinds of things would we want to see to do like a meeting or to do like, projecting different types of data visualization, for example, which is a different animal, and might get into that later in the year. But yeah, that might be useful too to be able to. In fact, it's one of the reasons I got into an interest in VR was that you can take like a simulation or like a bunch of data as a point cloud, and walk through it or look at it from different perspectives and get different insights about it. That's maybe like an immature way to think about data visualization, but it's that's a direction that could be done.
well, yeah, and I know, like, I don't know if you mentioned this later, but I know people, and I think this is what Hussein's doing, but like, you taking, like, being able to zoom into a model of the brain and walk around in it and, just like that. Um, I've actually wondered, and uh, um, I'm on a little bit of a kick, and again, I'll cite our ever present, um, non physically present, but ever present in our hearts and minds, angel or avatar, whatever you want to call him, Avery. I had a conversation last night about Avery, and I said to Avery, I'm really on this kick right now of visualizing or creating diagrams for theories, like theories and theoretical like developments where you want to go in them. And so we did a little bit of that because Avery's fleshing out a theory in their spare time, about some other stuff we'll talk about later, perhaps. But what I would really like to do is, like, I made a model outside of that conversation, outside of that conversation, in an uninvited talk, as we're calling them with one of my friends now. Um, I was using a whiteboard to describe something that had a few different dimensions, and I tried to put it on this 2D space. And I would love to have a 3D model space, like even a diagram, like a simple diagram, but that actually had a more functional. Like if I could go to, um, I may be able to show it very briefly. It won't. It's been partly erased, but like just to kind of put it on camera to reference later.
All right.
Let's see if this will work at all, or my camera will work. Nope. If I turn this off.
Background, yeah.
Let me see if I can erase that in the meeting. The video virtual backgrounds. Okay,
Yes.
let's turn this off for a second here. Okay, let's try this for take two. But yeah, it's kind of reversed, I think, for you, but there's like a timeline, and then there's these sort of like things about like ranges around these time points, So even being able to like do something different with this view, or like zoom in, or like go like physically go to a point,
Mm-hmm.
and then the perspective from that viewpoint relative to what the point can see would be really cool. And then there's these other like things that I'm referencing that are these like longer transcendent things that fill the timeline space, but in a different way. And being able to kind of toggle between these sort of lenses, I think would be really cool. And it's sort of like a way of embodying. There's sort of an interesting tie to embodiment in general, because it's sort of part of why this diagram came up, and I'm not going to really like explain a lot of what it meant right now. But where the diagram comes is like, the difficulty of communicating certain like perspectives or what like it was it last week we had sort of this conversation about it's a little bit akin to the conversation we had last week or the week before where like there's some sort of like different cycles of development, like there's like the AI winter and summers, but there's also different like collective efforts of development and interest and like relevance and societal space or influence or opportunity or incentive or disincentive. It's kind of related to that. And then like I think it'd be really cool when teaching or when offering context to a space to create a visualization of those different periods to some extent, or at least like from this, make it embodying. How one of my actually this is a bit of a I'll put it this way. I'm not going to say everything about this. One of the things I would like to do if I have infinite time and a project I would seriously like to work on has to do with what I am talking about in a much more concrete sense of being able to walk through spaces. I don't know, but like spaces that are relevant to. Hold on a second. I'm gonna write something down.
Yeah. I think that the walking is the embodied. We didn't talk about that directly, but yeah, there's a embodied aspect to that. Like you're walking through a space and you're tracking objects and you're kind of putting together ideas. So we just sit there sometimes and read a paper, and it's in 2 dimensions, and we have things in different places in space. And sometimes you'll do in your notes, you'll like create a box or you'll highlight things, put a bracket, and those are meant to be placeholders in the space. You think about it as a 2-dimensional space, and you're basically linking those placeholders together. And so you're pulling those things together, and then you're synthesizing the material. You're putting and have an output of this is what this means. So you don't want to take everything in that space. You want to bracket parts of the space, link them together, have like maybe some interpretations of that. Now imagine that in a 3-dimensional space with virtual objects, or like if you represent like parts of a paper as like little balls. And each ball you could click on it and say, this is this piece of the paper. Some of the older VR did that. Like people would create these interactive applications. They were like on CD-ROMs. It's like like in the late 90s, early 2000s. And they'd have like, you'd go through a room and you'd like click on things and you could say, this is, this clock is from like the 19th century and whoops. Okay. And then so it would be like you'd link these things together. You'd have like the information. Oh, okay, there we go. You'd have the information in text, but it was like distributed in space, and you could connect it to an object and you could see what so it's very much like that, except like what you're saying, there's an embodied aspect to it that we don't talk about too much, because we talk about embodiment a lot, but not that sort of operational aspect of it.
Well, yeah, and almost like embodiment, but like this is not the right way to say this or the best way, but like embodiment from the other direction of like not from our body to these objects, but like making objects. I just wrote on my whiteboard, making some incorporeal things that aren't going to exist. Giving them a more physical, tangible representation in a virtual space. I think that's a very interesting thing to do. Okay, take care.
Yeah.
I think that would be very. I think there's something to that, and I think there's actually like there's some. There's yeah. There's some existing stuff that ties into that well. But yeah, anyway, I don't want to divert too much from things. But yeah.
Yeah, I mean, it's a great conversation. Amanda, did you want to say anything?
I guess, I don't know, as a counterpoint, I think that good writing can successfully lead a reader through a multi-dimensional space just with, linear words on a page. That's difficult, but I think that good writing can do much of what certain virtual realities could make easier.
Yes.
I'm not saying that that these tools wouldn't be helpful, or that they wouldn't like bring in a novel way of organizing thoughts, but when I'm thinking about like the tools that would help me sort through things, what I always go back to is like, no, I need to work on my writing skills.
Oh yeah, that's always important. Yeah, it's like it's like kind of what we talk about with ChatGPT. You have like you could put in something and like a couple of prompts, you could get this nice outline of a paper, and is that what you want to do, or do you want to work on your literature review skills and then use that as a basis for confirming things? And it really I think a lot of people are kind of hoping that replaces the skills that you need to have really to.
It never will.
Yeah.
See, that like bot generated writing is exactly the kind like I think that will never be able to like synthesize things on this higher level or do the kind of writing that would help you make sense of I don't know, of these complicated topics. When I say that good writing can like do a lot of what maybe like a 3D world, a way of organizing your ideas. When I say that good writing can kind of talk about that 3D world, or however many dimensional world. Yeah, that's exactly the kind of thing that I don't see ChatGPT ever being able to do.
No, and I think that's I think my add-on to that is I think Amanda's how do we say it? Not really, I don't know, critique, but like your point to me brings out an extremely it points out like something extremely pertinent that I think is something many people with many technologies are very inclined to overlook, which is that it's sort of like the explanatory bottleneck, or that like good writing in the way that we're talking about it here is essentially you would have to be able to you can't get past it. Like if you are actually trying to build something outside of it being sort of generatively black box put together, which is kind of where we're at with a lot of stuff. But if you're going to do it in the Feynman way of like, oh, I can build it, right? I forget if I was just saying his name right, but Richard Feynman, the business guy. If you want, like, if you can't explain it, you don't know how to build it. Like, if you can build it, you know it. That kind of stuff. And it's like, well, and I'm not, there's certain things that I have flexibility about, but I think like the bottleneck of it, or the limiting thing is like you have to have the articulateness of good writing to really be able to functionally do some of the stuff with it that you want to do. And there's not really a lot of way around it. Like maybe you can't write it beautifully in like the English language, but you have to be able to have the same explicit articulateness when you're coding it if you want to do interoperable stuff. And I think that points out a major issue with like machine learning is that, well, because we don't really have the specificity of articulation, we can't augment it. It's just this random stuff that just the sausage is made somehow, but we get this thing at the end, and that's great. and it's not really the articulation. So the articulation problem is still there. And obviously I'm kind of, there's a lot of ways you could critique what I'm saying about machine learning right now. But for the sake of what I'm getting at about writing, like, yeah, like I think not only is it like good writing can cover all this, but also in a sense, the good writing, I keep wanting to make these weird comparisons in my mind to like the good regulator theorem, like the good writing theorem. Is like you have to have the writing will ultimately, the writing or the regulator would have to have some like specificity relevant to what you're trying to write about, and there's not really a way around it if you're trying to actually have manipulation or coherent interaction of an attempted control, or you're trying to communicate in quotes to it and from it. You're gonna have to have that. And that's I think that's some of the hardest things, and I think a lot of great scientists and people understand that. But I also feel like that's kind of one of the most common. Like, I think that I wish that was more explicitly talked about sometimes in a lot of like intellectual or academic writing, because it's kind of the game is a lot of the game seems to me to be. And I haven't thought about it until Rep saying it this way, but a lot of the game and all this stuff seems to be, well, how much can you get away with kind of fudging or BSing that space? It's like, well, I want to, what's the dance around that limit that you're doing, and how much are you aware of that, and hoping other people like look at that the same way you do, or are objective, or saying, well, my limitations are X, Y, Z. I think that's sort of the academic work about it all. So anyway, I digress.
I like the every good regulator theorem metaphor. I think that's actually pretty great.
I get in those places I'm talking about it in my mind, and it's sort of like impromptu, and they're uninvited talk, and it's like I keep wanting to say I keep wanting to literally interchange the words in my mind. It's like, well, the function's aligning too much tonight. And it's like, so it's sort of like fake every good writing theorem, regulator theorem. Yeah, sure. It was an interesting journey to go down. Anyway.
So, yeah, that's great. But I did want to talk about another thing, and this is something that goes back to a long time ago in our meeting series, back to 2021. And I know Jesse will remember this, but Amanda wasn't here. So this is a blast from the past. Yeah. What was that?
Fresh off the pandemic era.
Yeah, actually. So we talked about this idea of double descent. And I know Jesse actually brought it to one of our meetings once, and he said, "Was this, what is this? I'm interested in this," but we couldn't put any words to it really. And so we've spent a couple of sessions talking about it, like 20 minutes or so, but, didn't really make a lot of progress on it. So this is what double descent is, if we can review this. We'll zoom in here. This is from an old tweet. This is from some of the materials we reviewed in 21. So this is basically the idea. You have flexibility versus error. So this is flexibility and error. And then this is the training error. This is like a machine learning algorithm. And you have a bunch of data and you're putting it into the model. And this is the training error, which is minimized over time. So the error goes down, flexibility is going up. And then you have this testing. So you divide your data into a training set and a testing set. The training set is the set, of course, that you want to train your model on so it can learn patterns and extrapolate them. And then the test set is the data that you're presenting to say, what is this thing? So it's putting it in a category, or it's identifying it. And what you'll have is you have this double descent thing. So you go, in your test set, you have this decrease in error with an increase in flexibility. And then you have this point where the error increases in the middle. And then it decreases back again as you go down flexibility. So there's this interpolation threshold, which is where the error goes up and then it goes back down. So there's this point in the testing set where you get this double dip. So this is the idea here. It's a U-shape. The U-shape comes from the fact that expected predicted error equals irreducible error plus bias squared plus variance. As flexibility increases squared, bias decreases and variance increases. The sweet spot requires trading off bias and variance, and so this is something that we worry about in machine learning with bias and variance. A model with an intermediate level of flexibility is the sweet spot. So it's somewhere in here or in here, you know. So it's not like like in the training error example, it's just a straight line optimization. In this case, in the testing set, it's not so much, at least in terms of test error. In the past few years, and particularly in the context of deep learning, people have noticed double descent, where you continue to fit increasingly flexible models that interpolate the training data, then test error can start to decrease again. So this is where we have these models, we have these, I guess, neural networks or some other type of model that, you know, the model becomes more flexible as it increases its information. So the training error, we might expect it to decrease with, as the error decreases, the flexibility increases. You're training on more and more data, and it's able to generalize more and more. So it's more flexible with respect to, you know, it doesn't just like identify something at face value. It has a little bit of generalizability. But then, of course, that's the training set. The test set is quite a different story. So we talked a lot about this. We talked about some of this, you know, where we're doing with large degrees of freedom, 20 versus 36. Then we look at this is an example here of this kind of a model where you have a large number of degrees of freedom. And then you see the training set, of course, the training error decreases in this model, but the test error bounces all over the place, eventually settling at a very high rate of error. And so this is basically where we need to worry about these sweet spots. And this is basically the opposite of what the bias variance trade-off says should happen. The bias variance trade-off being this topic in machine learning where you want to optimize the amount of bias versus the amount of variance in the data set. There's a paper on the optimal perceptron. Can it generalize or not? We talked about high dimensional dynamics of generalization error neural networks. We talked about this paper on a jamming transition from under to over parameterization affects generalization in deep learning. So this is, I guess, a physics-based paper that talks about, you know, some of the aspects of generalization and parameters. This is the dipping phenomena, which is actually gets into this topic at a little bit more theoretical, from a more theoretical point of view. So this paper talks about classifiers. One typically expects classifiers to demonstrate improved performance with increasing training set sizes, or at least to obtain their best performance in case one has an infinite number of training samples at one's disposal. We demonstrate, however, that there are classification problems in which particular classifiers attain their optimal performance at a training set size which is finite. So this is where we have this problem of you know, training and then the test set, and the test set, of course, is not optimal in the same way the training set is. Whether or not this phenomena, which we term dipping, so this double descent is dipping, we call it, can be observed depends on the choice of classifier in relation to the underlying class distributions. So whatever the statistical distribution of your training set is, can affect the testing set, nonlinearity or this dipping. So it's kind of an interesting point here. Again, they show the idealized learning curve for training a model. This is in terms of training size versus error rate. So the error rate goes down as the training size goes up. Instead of flexibility, we talk about training size. So the more data you have in terms of training the model, the lower your error rate because it's seen more examples. This is the distribution of two class data to illustrate basic dipping. So in this case, you have two classes or two modes. So you have two sort of average modes. So, like we think of usually we think of the idealized distribution, which is this dotted line here, which is where you have a single mean and regular standard deviation, and then that's an easy example, Gaussian. This is, however, this black line is where you have a multimodal distribution. So it's distributed around two means, and the standard deviation varies between these. The support of these parts of the distribution are different, and so your standard deviation is not going to be straightforward to measure in that entire set of data in the training set. So then there's this dipping learning curve for three classifiers. They tested on three different methods: Fisher discrimination, logistic regression, and NMC. Then there's this aspect of delayed dipping where you show this learning curve for the MSC, NMC based on the two-class distribution, error rate versus training size. Training size, again, as it gets larger, the error rate decreases, but then you get this increase as the training size gets larger. For some reason, the error rate increases. And maybe it's because you're treating it as if it's a Gaussian when in fact it's a complex distribution. So you're seeing more examples that it's kind of treating as like part of a unimodal distribution when in fact there's much more variation there. And then this kind of shows some of the some details on the double dipping aspect. So there are a lot of interesting things here. There's the peaking phenomenon, which is another thing that they've observed that's part of this double descent phenomena. And then the two models of double descent for weak features. So this actually is the double descent risk curve. This qualitatively describes the out-of-sample prediction performance of several variably parameterized machine learning models. So out-of-sample means it's just an outlier. It means it's, usually we have our sample is this unimodal distribution with what they call thin tails. So there's some things outside of that standard deviation range which we care about, but we don't really talk about that too much. Out of sample prediction just simply means it's way out in the tails. It's something we won't see very much if at all. And your model needs to predict those things. So, you might have things like, maybe like 1,000-year weather events, which you're not going to see very often. But you have to still be able to predict those things properly. So you might use some scheme to allow the model to see those examples, but it's not going to be, it won't see it a lot. So I won't really think that it's something that's probable. So this is out of sample. It's a whole class of problems. It's a whole research area, actually, where they talk about this out of sample prediction. So, this is another issue with this multimodal distribution where you have multiple means, but you also have these long complex tails and like information, data that isn't really fitting into that unimodal model. So again, they talk about a double dipping and double descent and finding the sweet spots in the training, in the testing set that will give you the lowest error. So now it becomes much more than just kind of like waiting for the algorithm to converge, and more about like finding the actual sweet spot where you get the best performance. It's much harder. And so this is why we're interested in this issue. So this brings me to the reason I'm kind of bringing this back into existence, breathing life back into this, is because there is this paper that came out this week, or I guess it was a blog post. Chris said, I guess, I am a data scientist at Stitch Fix, and apparently in the Slack, Morgan mentioned that he was familiar with his work, so this was posted in the Data Science ML channel, and Morgan said, "Oh, it's always great to see a piece from Chris." So this is a nice, so it's kind of verification that it's a quality post, I guess. This is actually interesting because we've talked about double descent in terms of the machine learning aspect. And we've talked about in terms of learning, which is, you could extrapolate it to human learning, of course, and you could make the analogy. But it's not immediately apparent how it fits into human learning. We know that if you give a machine a bunch of data, that it learns, and that you can test it, you can recall that training to classify things or to identify them. This is double descent in human learning. So this assumes that humans have a similar learning pattern to machines. Now, this is, of course, like human learning in sort of in situ in adulthood. And what I mean by that is that they don't really consider development here. Because we've talked about development as being this thing that, we have, for example, innates. We have things that you're kind of born knowing. And then you have this process of learning that's very different from adulthood. This ability to like learn things from very little data and things like that. So we don't consider that here. But just let's consider human learning as like an adult thing. And a lot of the science of human learning, a lot of psychology and physiology and behavioral psychology, that behaviorist approaches, they kind of go from that assumption that you're just testing someone in adulthood, you give them a bunch of tasks, you look at their performance, and you can get some sort of characteristic function that describes that performance. So this post, he talks about in machine learning, double descent is a surprising phenomena where increasing the number of model parameters causes test performance to get better, then worse, then better again. It refutes the classical overfitting finding that if you have too many parameters in your model, your test error will always keep getting worse with more parameters. So that's why I talked about parameters in there. I forgot about that, but there's this aspect of like your when you add parameters into the mix, your test error will get worse. And so this is overfitting. It's kind of like if you've ever done fitting to a polynomial. You can fit things to a polynomial, which is like where you have, actually I can show this on the Jamboard. So a polynomial is where you have a bunch of points in a space that you want to predict over, right? Like they're just all over the place. And what you can do is you can do a couple of things. You can have a regression model, which is linear. So you have like a regression line here. And then you predict the points relative to that regression line. And then you get an R squared, which is the fit. You have a nonlinear regression, which is like maybe something like a log linear function like this, where you expect some saturation at the endpoint here. And that also has an R squared. Another thing you can do is a polynomial. So a polynomial has this property where you put in a number of parameters. So this is like I think a second order polynomial, or this is a second order where you have two sort of points where it's moving towards. So the idea of a polynomial is that you want to cut through the space, but you want to predict locally in certain parts. So you basically predict that the points will mass around the lower part of this and the higher part of this. And you can do this infinitely. You can have like n-order polynomials. So an n-order polynomial will just be like, how many of those means do you expect in your data set? Remember we talked about the the multimodal distributions, which are, not the unimodal distribution, but they have multiple mean points, I guess. And they just call them modes. And they have a complex relationship with outliers and so forth. This is a trimodal distribution. So we have three modes where there's a sort of a mass in the probability distribution here. It's very complex. This would be like a third order polynomial. Okay. So this would fit the data, but overfitting is where you overpredict what the actual structure is. So maybe you say, okay, it would be just good enough to have a linear regression model. It would predict most of the variance in these points. But I want to use a polynomial. I don't care. I'll use a third order polynomial. And I'll get a third order polynomial. I'll kind of move through this point cloud like this. And, it predicts it, but it overpredicts. It kind of overfits. So why is this a concern? Well, you could have like a shape, like an elephant. Let's draw an elephant with a trunk. And this elephant has like, I can put a tail on it too. So the elephant maybe has like points along this. This is just a shape of data points. You look at a data point cloud, sometimes it forms like a cloud, looks like a cloud in the sky. Sometimes it might look like something. We use topological data analysis sometimes to get at like some of these shapes. But let's say we had a bunch of points that look like that resemble an elephant. Now, what is the best function that fits this? Is it to draw lines around the edge and say it's an elephant? Or should we just use a linear regression model and say the points fit this model with a certain R squared, which is not great, but it's describing the model better than the elephant? Well, the elephant, just drawing a line around the edge of the point cloud gives us this high order polynomial, so this n is high. And it fits the data really well. Like, it describes the data as an elephant, but it's overfitting the data. It's describing the variation of every single point. And that's not really what we want in our model. What we want is to have a generalized model. So we want a generalized function that describes the structure of the data, but we don't want to describe every point perfectly. We actually want to have some variance. We want to have maybe not an R squared value of 1, but like an R squared value of like 0.8, which would be like, it would be kind of low, but it would also allow us to generalize from that line. So this line, we don't, not every prediction will fall on this line. Sometimes there's going to be things that look different from the archetypes. And so those will be points out here. And so we want to represent those points further out. So if we think about it as like a linear model, again, we can have like this. We have a bunch of points. And to describe this, we'll do a linear model, linear regression. So we'll draw a line through that. We'll give it an R squared of like some R squared here. I'll actually put the exponent. And then we have this sort of error bar, set of error bars, I guess, or region where our model will generalize. So our model will generalize outward from this line. So anything that falls within this hatched region will then be successfully predicted. So this is why we care about, like, we don't want to overfit things. So this is kind of where this is going. And then the idea, though, is to link this with some of the models we've come up with for human behavior. So he talks about language learning and overregularization, so that, it actually talks about development a little bit here. So I don't want to say that he doesn't do that, but he's not considering some of the things that we talk about in development. Let's just say that. So when kids are learning to talk, they often use a correct form of regular nouns and verbs, as well as irregular nouns and verbs. So it's shoes versus feet, dogs, walk, jump, or irregular or regular nouns. Feet, mice, went, and broke are irregular. But at a second stage of development, they start to overgeneralize certain grammatical rules. So there's this overgeneralization of learning. Feet becomes foots, mice becomes mouses, went becomes goad, because you're learning different words and you're putting them together and you're saying, oh yeah, there's this, it makes sense maybe that went is to go, and then you goad, you went. So you're generalizing in a way that's incorrect, but you're still doing it. So this is what he's kind of getting at with this idea of, generalize, this, why you get this error in the middle of training or in the middle of like this region of, so you don't see it in the training set. The training set is just learning these terms. But when you're actually testing, then that's where you're starting to get these errors, because the testing set is saying, well, if A plus B equals C, and those things go together, then these rules should follow a certain pattern that they don't actually follow. And so, language isn't perfectly logical, which is why we can see this sort of error. You're trying to learn individual cases as opposed to overarching rules. And so English tends to have a lot of idiosyncratic rules. So maybe English is particularly prone to this, whereas another language might not be. But I think a lot of natural languages have that aspect. So he talks about language models, and then he gets into some development, but not a lot about it. It's more about learning the language than about development. But in any case, the other thing he talks about is U-shaped behavior growth. And so U-shaped behavior growth this is U-shaped behavioral theory. This is actually from child development. It has its origins in that. So children display a U-shaped learning curve in understanding physical properties such as sweetness, with children in an intermediate age believing that if you mix together 2 glasses of equally sweetened water, the resulting solution will even be sweeter than the original. So this is where you're taking this idea of physical properties, and he's looking at with age, you sort of have this understanding of physical properties. You then extract rules, but the rules aren't always correct. They kind of operate on this rule that, I understand the properties. I have a simple rule of assembly. And then, this continues till at age 8. Then you start to learn that, okay, maybe you don't always do that. Maybe there's some other rules that are in play, or maybe there's individual variation. So then you start, after age 8, you start to go and think that way, and then you get things correct again. So you also see this with water temperature. And so your children try to generalize a newly learned principle, additivity, to a domain where it shouldn't apply, concentration of a solution or temperature. So this is trying to generalize. So U-shaped learning also exists in social cognition, motor coordination, gesture recognition, memory tasks, and other types of U-shaped learning. So does this teach us anything about double descent? U-shaped learning curves are an interesting curiosity with clear relevance in psychology. Does it apply to neural networks? Other than the language example, which is possible that this is an example of U-shaped learning. So the way double descent is normally presented, increasing the number of model parameters can make performance worse before it gets better. But there's another even more shocking phenomenon called data double descent, where increasing the number of training samples can cause performance to get worse before it gets better. And this is something I think we talked about in the 21 in the session of discussions in 2021, where you have this training sample aspect. These two phenomena are essentially mirror images of each other. That's because the explosion in test error depends on the ratio of parameters to training samples. As you increase the number of parameters, double descent, the explosion occurs while transitioning to an under-parameterized regime, P or N over P, to an over-parameterized regime, P over N. So P is the number of parameters, N is the number of samples. So in other words, you don't want, like I showed you with the elephant, you have a number of samples here. I think you have 15 or something. 17 or something like that. You don't want to have a 17th order polynomial that describes 17 data points. If the n is 17, you don't want it to be a 17th order polynomial. And you can describe this elephant perfectly. You can draw it out, the shape of it. But it also overfits the data. So it may not be an elephant. You may just be seeing an elephant. You may just draw it out with a polynomial. The 17th order polynomial then would be totally inefficient for this. What would be efficient is a low parameter model that captures all of these points. And that's what he's talking about here. And so sometimes there's this in real life, though, we don't know how many parameters there are in the actual data. So we have a lot of parameters, we're fitting them in, but we don't know what the optimal number of parameters is. Eventually, we kind of figure that out as you run through the sample, and then as you saw in some of the cases, sometimes the testing set, the error just goes up after a while, and that's because we don't ever really know the true number of parameters. So this is data double descent here in this figure. So the training sample size is 10 here. We have our trained samples here. We have our true function, which is what it's supposed to look like in nature, and then the model fit, which bounces around the true function but doesn't really ever reach it. It kind of misses it here in the middle, but kind of comes close at the end. You see this a training sample size of 50 and 200. You see like where it fits more closely to the true function when you have more samples, when you have this second order polynomial. So the idea is that, your second order polynomial is like a fifth of the n of 10. So that's, giving you like variation over a fifth of the data set. So, the number of points where there's a mean. When you get up, when your sample size grows, then this number of parameters is much lower proportionally. And so it's giving you like this data, like the distribution has a sufficient support to classify these things in a way that's like informative. And so you get this, it hews more closely to the true function. And again, the true function is just drawn through the point cloud. It's just, like I said, it could be like a linear function, it could be a low order polynomial, but it gives you a decent fit to the data. So in some ways, the language learning example is a reasonable analog of data double descent. Children start off in an over-parameterized regime where they have essentially memorized a small amount of training data. Eventually, they get enough data that they can learn some rules, which they unfortunately overgeneralize to irregular examples. Similar high test error in a machine learning setting. So similar to that. Only when they have been exposed to a large amount of data have they been able to build towards a more flexible and correct set of rules. So this is, I'm not ready to say that U-shaped learning in human brains is identical to double descent in machine learning. Performance degradations in U-shaped human learning are typically confined to local subsets of tasks rather than global performance, and these local degradations can emerge in deep networks, even without the exploding parameters observed in ML-based double descent. So a lot of machine learning models have a lot of parameters, but they also have a lot of data. The thing that you're kind of worried about is that, how many parameters do you have relative to data points? And so that's where we're getting at. A lot of large language models have, many, many parameters, millions, if not billions of parameters sometimes, and many, many, many test points or samples. And so, it's worth thinking maybe about some of those aspects of the large language models. And so he cites this Schaefer et al. 2023. This is a new paper on double descent demystified. So this is something that I didn't put in our folder, but I'll put it in there. This is a new paper on this topic. And then the blog post from Danielle Witten, which we saw earlier. All right, so are we still there?
Yep.
All right.
Yeah, that was interesting.
Yeah. Okay, so any questions at this point?
No, I'm going to be diving into data science more, so I think I'll be encountering this more in the future, but I need to dive a bit deeper into it before I can say more fully.
Yeah.
And I'm glad to have that review from, the throwback.
Yeah. All right. Amanda, do you have any thoughts on it, or?
Not yet.
Okay. Well, when we went over this in 21, it was like we were mystified. So there's a demystification paper in there. I mean, it's not an easy thing to wrap your head around, but like, I mean, it's it's one of those things that, as a casual user of models, you don't really think about or care about so much. But like, it's interesting, I think, from a statistical standpoint. But it's also maybe a philosophical standpoint on like, what do we like need to know? Like, how many samples do we need, or what do we actually need in terms of like training set data? So I mentioned before. Oh yeah.
It also
go ahead.
kind of relates to the question of like what counts as knowledge.
Right. Yeah, definitely. We don't know. Like we talk about data points. It's like we don't learn data points necessarily. We learn knowledge, which is like how do you quantify that to say how do I characterize it with a function?
Mm-hmm.
But yeah. When I saw this article, I first thought he was talking about U-shaped like performance. So like there's actually an idea in human performance, which is this idea of the U-shaped curve, and this is something that they measure arousal with. So it's like what they call the Yerkes-Dodson law. So this is something you can measure from like heart rate, or sometimes from other types of arousal mechanisms or measurements. So the idea is that you have this, like, why it's not letting me write here. Okay. So you have this curve like this. It's an inverted U, actually. And the inverted U describes this median sort of optimal area. And so the idea is that you have low arousal in these regions, and high arousal here, in the middle. And so this is like, you could have like a state of low arousal, and then it goes up in the middle, and then it goes down with high arousal. Usually this is with respect to something like some stimulation, like attention or emotion. So we usually think about it in terms of attention or emotion, and then this is arousal. So the intensity of arousal, so the idea is like you can be in states of very low arousal and very high arousal, and when you're in high arousal states, or I guess arousal would be here, right? And then this would be the amount. All right, and then so the idea is you have a low, or I guess not amount, but like this is what this would be. Anyways, the idea is if you're in low arousal states or high arousal states, your attention breaks down. So if you set attention as like a function of like maybe like ability to track a target, all right? If you're in high arousal states or low arousal states, you can do that. If you can't do that very effectively. So like if you're tired or if you're angry, for example, you can't really track your target very effectively. But if you're in this median area, you can do so very effectively. Mm-hmm. And so sometimes you want to keep yourself in this region as opposed to these regions. You can think of video gaming or driving where that's the case. If you're falling asleep, your driving is, impaired. If you're really angry, your driving is also impaired. But if you're in the median range, your driving is not impaired. And so that's the idea of an inverted U. You get this also with other things. But the idea here of the inverted U is that, I don't know how it relates to double descent, but it kind of has the same principle where, there's this sort of, this is more of a physiological function where, you have this regime where you're getting information and you have to operate on it. Your underlying physiology has to be able to deal with the information coming in a optimal manner. So I thought he was going to bring this up, but he didn't. But I like this idea of like, kind of fitting, like saying, well, how many parameters do we need to fit to the data. So I don't know what a parameter is in terms of human learning. I guess it's like how many rules we have or something. Like I said, he talks about development, but he doesn't talk about some of the stuff we've talked about with respect to innates, or with respect to critical periods, or with respect to some of the other things, like being able to learn generalize with very small data sets. But I guess maybe there is something there because he talks about the relationship between the number of data points and the number of parameters. So if you have a very small amount of data, theoretically you should need a very low number of parameters. But that doesn't make necessarily a lot of sense in a machine learning context, because we know that probably wouldn't work. So what is the answer there? I don't know.
Yeah. A lot of my mind is between this and even going back to like the good writing stuff and the good theorem, regulator theorem, and it's like if this sort of fits, and Amanda's point about what we need. Knowledge is sort of this contingent, like this sort of contingent or like fit. It's sort of the tension between sort of all possible things that the data or whatever could tell you, like almost like the full range of affordances versus the affordances that you want to look at or that are relevant, and just the tension between all that. So it's a lot of thought-provoking things in there.
Yeah, and then there's also a link between like attention and the number of data points. So like we have access to a larger number of data points. Attention restricts that flow of data points at any one time. So if we're taking in a lot of data, we don't know what to do with it necessarily. If you took in all the data that you're exposed to, you would go crazy because you couldn't distinguish anything. So your perceptual systems filter that. There's attention, but there's also dynamic range. But that sort of thing is, of course, dynamic range, for example, was something that's evolved. So if you're like a frog or an insect, you might have like a sensitivity to very high ranges of frequency, whereas humans don't have access to that. But that's a specific thing to what their environment, right? So
they would translate range stuff.
Yeah.
Really?
But attention is maybe similar to that in that you pay attention to, like, you focus your attention, or in fact, babies don't focus their attention the same way that humans do, but you have this mechanism for winnowing down that information. But that's something, we don't have in machine learning models necessarily.
Right. Yeah, that's what I was going to say too. Is like going back to Amanda's like critiques of GTP and such. Is like there's not really. And I remember like machine learning papers and like attention is all you need, or like attention in this way, and like I don't really. I saw them many years ago, and I didn't know what any of it meant at the time. So,
well, their approach to attention is a bit different. It's more like I just like focus on features, which is I guess similar, but it's not what I'm talking about, which is like a constant stream of information that you can like take. You don't necessarily cut it out. It's not like you're just like reducing the image, say, to a set of features, and then figuring out what those are. It's like you're just kind of, moving from thing to thing, and there's like a subconscious, and then there's a conscious attention being paid to something, because we actually do take in a lot more data than we pay attention to. We have subconscious processing, and but and then we shift our attention at will. It's not like we just have a prior set of. So yeah, I think attention was a nice mechanism in machine learning to say we can restrict the amount of data that we're taking in, training data, and still get a good result. But then, is that going to impact the ability to generalize? I don't know. I don't think anyone's asked that.
I think that's actually a really great way to kind of differentiate along some of the embodiment and like AGI, AI stuff, and like that's something that I think is maybe not a question. Well, I mean it's a question, but it's sort of like a something indicating like a major space of like what is, how do we mitigate that? Like that's a significant gap between like natural and artificial intelligence right now, or not necessarily. I guess it's a gap, but like a like vast unexplored territory with a lot of vagueness and a lot of inconsistency in approach and not agreement, like untamed lands of that space. Cool.
I didn't know if Amanda had something. She was unmuted for a while. She had something she wanted to say.
Yeah, I was trying to think about how, I guess the short but maybe really unclear version is, I think that machine learning can be interesting insofar as it like might shed light on what are the possible dimensions of variation, like pretty generally speaking, and then how do altering those, like how do tuning those dimensions because there seems to be like a non-linear relationship between like attention and arousal, for example. Like that was part of the whole point, is there's these U shapes and it's not a straightforward relationship. So expanding beyond attention or arousal, or like quantifying those things in machine learning world in different ways. I'm curious like how much light that could shed on like dimensions of variation in the subjective space, maybe, like in subjective experience.
Yeah.
I don't know, or maybe it's too limited by just like, because all of this exists in computer land, and maybe that is like a fundamental like obstacle.
Well, I think I hear the I don't know. I made a better term for this one, like phone a friend Avery. Avery's voice comes to my mind a little bit here, and I feel like a lot of Avery's work is the yes and to that would be kind of trying to map out like these spectrums of a lot of those inner world types of, I don't want to say arousal, but like an inner world like processes, and like how much is there in this space. Like sort of like, I think a lot of Avery's attempts at in the inner world sense of it are, yeah, I guess a lot of like heavy theoretical like speculations about that space. I want to try to say more, but I can't. I don't know what to say on their behalf right now. So yeah, definitely to the point. I think I wonder about that too.
Yeah, I mean, what I have to say about subjective sort of experience is that, you know, you can think of like subjectivity as sort of like different ways of coming to a conclusion or having different paths through like a set of points that you're observing. So, you know, everyone's experience is different. If you take a piece of art, you know, I say, what does it mean? And people have different interpretations of it. So that means, of course, that they arrive at different conclusions from maybe the same input data. So if I were to take like an image and scan it and put the data points into an algorithm, it would converge, hopefully, on the right answer. But we see, actually, that if you train it and you get enough training data on that image, or like images, that the testing set doesn't necessarily reflect that. It seems like there is that sort of aspect of where the error rate may go up, and that's not necessarily subjective. We don't think about it as subjective. But there are ways you can model that. You can say, you know, maybe it is desirable, say, to have agents that have like a common pool, a training pool, and say, if the agent goes to that training pool, if you train the agent, say, outside of the environment and give them certain sort of representational aspects to their behavior. So we actually did this with contextual geometric structures, and I don't have the paper open, so I can't show this to you. But one of the things that I was interested in with that is looking at subjective, or what I call polysemic interpretations of data. And so that was where you would have like the data you could train the system on data. You could give a training set. And then you'd have these agents that would come in. Yeah. Actually, it was in a different paper, so I can make that paper available. So you basically have these agents that have they're representational heavy, and that they have a representation of like a cultural representation. So they have like this representation of this phenomenon at different degrees of, so they have this pre-wired representation basically. And then you throw them at the data and you say, interpret this. And so the agents should give like different meanings to the same data set. So it's not error so much, it's actually these interpretations that emerge, interacting with the representation. And so this is something that, I don't know, really implemented it much. So I couldn't really say what the upshot or the take-home message of that is. But it's, it's definitely like you can do this sort of thing. And polysemic just means like you have a symbol and you have different interpretations or multiple meanings. So like the Magritte image, this is not a pipe, that you have a picture of a pipe and it says this is not a pipe. It could be a pipe, it could be something else. If your agent is trained on a certain representation of what physical properties are associated with one another, it might have a very different interpretation than another agent with another architecture or a different set of properties.
Yeah, that's really interesting. And I think that gets at what I was trying to explain by like dimensions of variation in subjective phenomenal space.
Yeah. Yeah, definitely. So yeah, I think it's probably the end of our time this week. So thank you for attending the meeting, and thank you, Sushmant, for showing off your work from DevoWorm. I know we don't talk about DevoWorm as much in the meetings, but sometimes it's important, especially GSOC coming up, to find those. Yeah.
I wanted to kind of, there's a few things we didn't cover this week, but that's fine in terms of other stuff. We didn't get accepted at the We Robot paper that I did for DEI, which I didn't totally expect, but I think we'll have a bunch of good posters to make. Also, we should talk about Bond Sustainable AI next time.
Okay.
But as far as Google Summer of Code, I may message you a little bit in like later today and tomorrow about things to kind of set up ahead of, the 4th. So yeah.
May the 4th be with you, I guess.
Indeed.
Yeah, we will set that up, and then people coming in. Again, if you don't get accepted to GSOC, you can join our group. We're going to have a working group, at least one working group. We'll have like the working group in Orthogonal Lab, and then DevoWorm will have a working group for that project. That'll be separate because they have it's quite a different project. So but I want to have crossover between the two communities. Like I don't want it to be totally walled off. And so we'll have to think about ways to facilitate that.
Okay.
Yeah. All right. Have a good week.
All right. Take care, everybody.
Take care. Bye.